At the top of the 12th century Jagannath Temple, the main flag spends its days violently whipping in the exact opposite direction of the wind. And deep inside the Mahalaxmi Temple, an intricate 1,300-year-old architectural layout guides the setting sun down a 200-meter corridor, perfectly hitting the face of a stone idol, but only twice a year. Today, we have our own modern black boxes. We vote on electronic voting machines that cybersecurity experts confirm are completely immune to remote hacking because they lack Wi-Fi, Bluetooth, or any internet connection at all. It is incredibly tempting to look at these marvels and call them miracles, but treating brilliant engineering as magic is dangerous. When we stop asking how things work, we lose the ability to maintain them. Take the Krishna Bai Temple in Maharashtra. Modern contractors tried to fix the ancient stone structure by filling its joints with modern cement. By doing that, they unknowingly destroyed the building's built-in earthquake resistance, actively causing the walls to crack under their own weight. To preserve our history and actually understand our future, we have to strip away the illusion of magic. We need to reverse engineer the hard physics driving these impossibilities. Let's start with gravity. The Jagannath Temple towers 214 feet in the air. It is a staggeringly heavy stone structure, built without an ounce of cement, resting entirely on the soft, sandy soil of the coast. Ancient engineers employed a sandbox technique. They excavated a massive subterranean pit and filled it with sand. That sand acts as a structural buffer. If an earthquake hits, the loose grains absorb seismic vibrations, dampening the shockwave before it reaches the solid stone walls above. We see a similar mastery of earth at the Hoysaleswara and Mahalaxmi temples. Builders used interlocking dry masonry, where every stone features precision-cut joints that lock firmly under their own weight. During an earthquake, these stones do not break. They are designed to physically shift, grind against each other to burn off the kinetic energy through friction, and then gravity pulls them right back into perfect alignment. These ancient builders never tried to rigidly fight the Earth's movements. They engineered flexible structures specifically designed to dance with seismic forces. That same mastery applies to the invisible atmosphere. Remember that Jagannath flag defying the wind? That is fluid dynamics. As heavy winds crash into the curved spire, the air undergoes boundary layer separation. The wind splits, creating a low-pressure void directly behind it. To fill that gap, air flows backwards, catching the flag in reverse. Manipulating pressure is how we pull off modern miracles, too. Look at the air conditioner outside your house. It takes boiling hot air and spits out freezing cold mist. Inside, a compressor squeezes gas so tightly that it boils, forcing superheated liquid through a microscopic pinhole. Hitting the open space, the pressure instantly drops. The liquid rapidly expands, sacrificing its own heat in the process, and freezes in a fraction of a second. In Bhopal, engineers are using pressure to clean the sky. They built an artificial algae tree that vacuums up polluted street air and pressurizes it directly into a tank of water. This wet scrubbing physically traps the dust, while billions of living algae cells eat the remaining CO2 and pump out fresh oxygen. Mastering these invisible forces provides the technical foundation for controlling the environment across centuries of engineering. Sometimes the force you have to manage isn't wind or rock, but millions of people. At the Vaishno Devi Temple, massive crowds navigating a single, narrow 5,200-foot mountain path creates a very real risk of deadly bottlenecks and stampedes. To solve this, engineers drilled an M-shaped subterranean tunnel system straight through the mountain rock. Paired with cyber-physical RFID tracking to monitor density, the incoming crowd flows into a central artery and then automatically splits into two distinct one-way exit tunnels, permanently clearing the flow. You see the exact same logic applied to natural resources in Rajasthan. The ground there is hard and rocky, meaning when the heavy rains finally arrive, the water flashes into surface runoff and disappears before it can soak into the soil. Local engineers solve this by installing highly strategic velocity breakers. These are designed to disrupt the flow of moving water. By forcing the water to slow down, it percolates through porous rock, recharging dead underground aquifers and bringing dry wells back to life. The most elegant engineering solutions never rely on brute force to completely stop a moving mass. Whether you are dealing with millions of pilgrims or millions of gallons of water, you strategically redirect its momentum. Every one of these phenomena follows specific mathematical and geometric rules, from flags flying against the wind to buildings that remain stable for centuries. The unhackable dynamic coding loop inside a modern EVM shares the exact same precise logic as the physical geometry of an interlocking 12th century structure. Behind every one of these designs, the core philosophy remains the same. True engineering is a collaboration with the laws of physics, rather than a struggle against them. True innovation harnesses gravity, it leverages friction, it manipulates pressure, and utilizes biology to solve the problem. Science and physics serve as the instruments our ancestors used to ensure their legacy stands forever.